Today we'll dive into a full tutorial on image classification using PyTorch and discuss why PyTorch is a great choice for this task. Let's get started. PyTorch is a popular deep learning framework developed by Facebook's AI research lab. It's known for its dynamic computation graph and ease of use, making it a favorite among researchers and practitioners. Its flexibility allows for easy experimentation and debugging, which is crucial in developing machine learning models. First, let's set up our environment. Ensure you have Python installed. Then install PyTorch and Torch Vision by running this command. This installs PyTorch, which is the main library, and Torch Vision, which contains datasets, model architectures, and image transformations. Next, import the necessary libraries. Here is a list of what each library adds. Load and transform this dataset. This is a commonly used dataset for image classification. Transforms.compose combines several transformations. Transform.toTensor converts the image to PyTorch tensors. Normalize normalizes the image. TorchVision.dataset.cfar10 downloads the cfar10 dataset. The data loader command loads data in batches for training and testing. Then we have to define a simple convolutional neural network. Conv2D defines a 2D convolutional layer. Maxpool2D defines a max pooling layer. Linear defines a fully connected layer, and forward defines the forward pass of the network. Set up the loss function and optimizer. Cross-entropy loss computes the cross-entropy loss. SGD implements stochastic gradient descents with a learning rate of 0.001 and momentum of 0.9. Next, we have to train the network on training data. Optimizer 0_grad clears the gradients of all optimized tensors. Outputs equals net inputs performs a forward pass. The criterion command computes the loss. Loss.backward backpropagates the loss. And optimizer.step updates the weights. Now we have to evaluate the network on the test data. Torch.nograd disables gradient calculation. Torch.max returns the indices of the maximum values along a specified dimension, and correct over total computes the accuracy. Thanks for watching. If this video was helpful, please like and subscribe to our channel for more tips and tutorials. See you next time.